Even after 13 years, it's been fully published by Notch. What a hell of a game. Each time I see people mining for some diamonds, I immediately remember doing it myself after school for countless hours. But now that most of us have become adults ourselves, let's go onto the journey of finding out how Minecraft has been created in the first place, feature by feature, and watch me trying to replicate this legend of a game that has been hunting us to this very day. And in case this video is enough to satisfy your curiosity, please feel free to check out limited video course on Patreon. But now, without further ado, let's take a look at how to craft the world's greatest game. So, to find out which feature to start with, I want to take a look at Minecraft's earliest days. To discover the feature, this guy has been starting with 2. What you can see right here is Minecraft's so-called alpha version, which was made public in 2009. I mean, just take a look at how primitive and strange everything's looking. Almost surreal, right? So, the first thing I did was thinking, what of all those objects can be considered Minecraft's most basic element? And it didn't take very long for me to find out. It's the blocks. In particular, it's a custom mesh created just for the sake of this game. And now on the other hand, let's take a look at what we've got ourselves. Nothing. But that means nothing to distract us, at least. Or, well, unlike back then, we actually got a new tool at hand, which is game engines, like Unity for instance, which I'm going to use for our journey. So, to come up with those blocks, I needed to discover how 3D meshes work in the first place, which is by providing a list of vertices and a second list for the edges between those vertices. I also knew from back then that faces of 3D meshes are only one-sided, so as soon as you clip into them, they're gone basically. However, as it turns out, there was no need to provide information on the faces' directions, as that information can be derived from the order of the vertices. As you can see with this drawing, those vertices are ordered clockwise, and that means the face should be facing towards us. So the only thing I had to do basically was providing the exact information we just talked about for a cube mesh, and later on also for, Minecraft slabs and flowers and whatnot. And that's what I ended up with. Not a big deal, I know, but it's enough to keep going. Still, I felt like it was looking like more like Lego instead of Minecraft, so that's why I wanted to add textures onto the faces of the cube. And the way Minecraft is doing it, even back then, is by storing all those different textures in what's called a sprite sheet, which each texture having a distinct number you can just reference when creating the block types. So, for instance, for the grass block, you could just write a 0 on top of the surrounding faces, a 1 onto the top face, and like a 2 for the bottom face, and that's it. And I think that now is looking a bit more like Minecraft as like a Lego, right? But then I realized it would still look a bit awkward if the world consisted of only one type of block. So what I needed to do was finding a way to store all that different block types. And since I didn't want to write a lot of code, I hope you can relate to that. For each and every one of those block types, I decided to stick with a feature provided by Unity called scriptable objects that allow you to basically create a container for the data, so you can easily create a whole bunch of them and enter your respective values. And looking back at those blocks right now, I remember how glad I was knowing the most annoying part has been done by now, and I could continue with more engaging stuff. Next up, let's take a look at Minecraft chunks. And looking back at Minecraft's alpha version, you might already know single blocks basically didn't exist even back then, neither do they exist in the present day. Instead, Minecraft is building the world using whole chunks of blocks, which are like 16 by 16 blocks, and reach across the whole map vertically. So to me it was almost as easy as writing an algorithm to place one block right besides the other. This approach is particularly good when it comes to saving performance, as you can avoid rendering interfaces of the chunk. Although you have to watch out for transparent blocks, because each time you're dealing with glass, for instance, you have to make sure the other faces surrounding it are still visible, so you don't end up having a window into the void. And guess what system I've been using to store that information, whether blocks are transparent? It's those scriptable objects again. Those very scriptable objects we talked about earlier turned out to be the perfect solution, and I have to admit it was pretty exciting looking at what I got so far. So let's take a look at where our journey is going to take us next. Next thing I want to do is Minecraft's world, and I quickly realized I could create the world the same way I created those single chunks, and that is by using chunks as my new blocks. And if you'll take a look, you'll see that the original Minecraft basically does it the exact same way. You see, the entire world is just a grid of chunks, and I remember feeling like an idiot when I first tried to write the code down right away, as I hadn't defined the word size yet, and even if I had, we want the world to be like almost infinitely large. So what we're really caring about is what Minecraft has called the player's view distance. So when playing Minecraft, I'm sure you at least noticed once those new chunks popping up in the distance and older chunks disappearing behind you. So it feels like the world is expanding into the direction you go and shrinking the direction you came from. And that's what's caused by the view distance. So what I needed to keep track of was the player's position. And each time the player changes its current chunk, I need to update the player's view distance, which is set to 10 or 20 if I remember correctly. So next, if you're ready, we're going to talk about the most expected or unexpected feature of all. Just imagine my next step like so. I hit play to find out what my newly created world would look like, and what I was able to do was basically nothing. I'd been focusing on the map for so long I didn't implement the player, Steve, yet. So Steve, what's a Steve anyway? So let's fire up the old game again and take a look at what the true one should be able to do. Alright, so what we can do is look around, moving around with different types of speed, like when sprinting, we're able to jump and to fall, voluntarily or not. So that's Steve's basic movement. But since I've been using my custom meshes for basically everything so far, I couldn't just use Unity's built-in collisions. So here I had to come up with something new. And the system I came up with was by using rays. So those are fairly simple. You start at the player and continuously move towards the direction the player is heading. And as soon as you overlap with a face or pass through it ever so slightly, you know that a collision happened. If that very collision happened like too far away, or there wasn't any collision at all, there hadn't been any collision. And if it was too far away, we can just say, okay, it was like out of the player's reach. And using that system, I could easily check whether the player is blocked in whatever direction, like to the side when moving, or to the upside when jumping, and even to the downside. And if no collision happens to the downside, we know the player finds himself in the air and we can apply gravity to it. And you'll probably know, but setting up the camera sounds easier than it actually was, unfortunately. What you have to do is to just move the camera around as the user moves the mouse. So it's a decently easy thing to at least understand conceptually, although it took me some time, I have to admit. So after doing it, I was finally able to play my game, and what an awesome experience to be able to really interact with your media, like as you'd expect from a video game. However, there was one elephant in the room we still need to talk about to make my game a real Minecraft game. And surely you were waiting for the thing all along, and that is placing and destroying blocks, which I mean is Minecraft's core mechanic, and not sure whether the original one set it up like this intentionally, but as it turned out, implementing a complex system to add and remove blocks to the whole map wasn't even necessary, as I was just able to set the block the player was about to destroy to an air block, like when it comes to the block type. And when placing a block, it basically means nothing but setting the block in the grid right before the one you're looking at from an air block to your respective block type the player is holding at the moment. However, if you were to inspect the whole thing once more, you'd quickly come to the conclusion it still doesn't really feel that good or intuitive, and that's why I added an animation for breaking those blocks, which, funny enough, I think it was actually the only time I was using Unity's built-in cubes, which I modified using a transparent shader with nothing on it but those breaking pixels. So I was able to overlay the animation block on top of the one currently being destroyed by the player, and also to play the sounds later on. Or if it still doesn't feel like natural enough for you, that's because I also needed to add a durability to the blocks. In other words, each block should only vanish as soon as a certain time has passed. And this time, as you might have thought, you can too just use just enter the value within our scriptable object for that respective block type. And I want to take a quick moment to tell you how much I love it in game development and in programming in general. If you're able to use a feature you've implemented a priori, again in your next features, so you don't have to reinvent the wheel. You can just enjoy your creative brilliance. If you want to have yet another example for this, just take a look at how I needed to determine the block the player is looking at in order to destroy it, which once again was by using those very arrays we talked about earlier when it came to the player's movement. And although placing and breaking blocks look so incredibly good now, this video is not about me moaning on how awesome game development is. This video is about how Minecraft has been created in the first place, so I can't wait to head over to the next big step with you. If one thing's clear by now, it's that creating all of this has not been easy. However, you can benefit from me doing all the hard work if you plan to craft a similar game to Minecraft, or you just want to dive deeper into it. And you can even join my Discord to ask me for personal advice on your very own project by joining my limited video course on Patreon. So please just feel free to open a second tab to check it out, as I will probably have to raise prices at some point, depending on how many people will join us on our awesome endeavor. Anyway, when comparing the world from the original Minecraft to the one I've been creating so far, you can quickly see that I couldn't view it as a real world so far, as I was still missing on some important aspects, like terrain for instance. I obviously didn't want to stick with that warring wasteland forever, so I needed to find a solution. I needed to find a solution quickly, and just putting random noise on top of the blocks wasn't the best idea, as it would just cause the surface to look all messed up, like an old pillow if you zoom in real bad. So when searching for a solution to make my terrain resemble the original Minecraft as closely as possible, I encountered an old random noise algorithm called Berlin noise, named by its inventor, which when colorized looks like this. I mean, it looks a bit weird at the first sight, but those white mountains and black pits you can see right here, and basically everything in between, can be considered the ideal solution to generate some mountains or a noisy environment at most. So that was exactly what I was using, Not a big deal again, I know, but at this point I was just getting started. Finishing the terrain marked the perfect point for me to add a bit of life to my world, i.e. adding structures like trees or flowers, and even bigger ones like dungeons, which I obviously included from the project to keep it as simple for you as possible. And I was even able to include it pretty seamlessly to my world generation algorithm, as I could just use another Perlin noise to define whether a tree or a whole set of those should be appearing at a certain point, when I all of a sudden realized there was another big issue I didn't realize ever before. You see, since our chunks are being generated and populated one after the other on a second thread, meaning it is not being synchronized. Sometimes it happened that trees were suddenly cut off, when it happened that the trunk was locating on one chunk and the leaves on the other, meaning those leaves were either overwritten or just stored too late within the data. So I had to come up with a new way of making sure structures were being generated, and that was by implementing a system called chunk add-ons. So as the name suggests, the chunk add-on system kicks in after the chunk has been populated in the first place, and it works as follows. Whole structures, like trees too, are being viewed as chunk add-ons, meaning they enter a queue, which is chunk specific, and is being used to override the chunks after the population process, which unfortunately makes the entire creation process just a bit slower. I mean, it works, so I assume it was the bullet I had to bite, marking yet another small victory of mine, but also, as you might have predicted, there was an even bigger threat standing just in front of me. When looking at the order features have probably been implemented into the original Minecraft, I think it's safe to assume that what Notch was trying to do is to recreate Earth. And what he did was summarizing typical sets of flora and fauna to what you all know and love today as biomes. And again, in order to implement it, I knew that I couldn't just assign one biome to one chunk, as it would have made my biomes a square, and the whole world basically just a grid of strange, equally large biomes. Luckily for me, I sought advice at an old friend of mine, good old Perlin-Noise, and this time around I would separate the Perlin-Noise into some kind of peels to form my biomes. So I got my mountain biome, ranging from far right into light gray, for instance, and by having the Perlin-Noise scale a bit larger, one wasn't even able to see the pattern. And to obfuscate things even more, I put yet another Perlin-Noise on top of it to introduce what I called biome variants, whose Perlin-Noise was even bigger in scale. So that way, even within the meadow peel, I was able to handle two different types of biomes, which was pretty predestined to become a variant of the default one. So you got normal meadows and snowy meadows, for instance. And I was even using my good old noise for a third time to make for some wars and also caves, which is just a batch of air blocks anyway. And if you did it the same way I just talked about, you would notice pretty early on those borders between biomes are not interconnected nicely. So you also have to make an effort to find a way to interpolate the biome's borders to make the transition nice and smooth. And not sure what you think of it, but I'm kind of pleased of what I've been ending up with. However, there is one big part of Minecraft's gameplay I didn't touch so far, to save it for this very moment. If you take a look at Minecraft's name, you can see it has the string craft in it. So I couldn't really get to sleep while not having a crafting system implemented yet. And the first thing I did to achieve that, for me, was by creating the inventory, taking a look at the original once more. What we need is a UI opening up whenever the player presses a key, blocking the player from moving, and allowing him to inspect his items and to reposition them. And thank God we're using a game engine. I had the plan to just use Unity's built-in UI, whose sprite I obviously needed to change to match Minecraft's inventory's original layout. And after coming up with all the inventory functionality like dragging items, stacking them, and so on, I have to admit it was actually harder to pull off as I make it look right now. But let's focus on some more fun stuff before we take a look at the real bad guy who is known under the name crafting. So before facing the big bad, I thought it was time for me to make my game even more authentic. And that was by adding the player's HUD first and foremost the hotbar, also known as the Toolbelt, allowing you to select whatever item from your inventory in a rapid way. Again, using Unity's UI possibilities, it was quite simple, although I needed some time to befriend with those mechanics, for instance by using Unity's UI layouts. positioning those slots from the hotbar automatically, one besides the other, which was really worth the effort, I want to say at this point, as you don't have to make an effort anymore to align your elements in a grid or a line or whatever you name it. So what do you guys say? So to finally start off the crafting system, I added the option to let blocks open a UI when being right-clicked on, instead of placing a block right besides them, which would be very annoying. And that basically allowed me to add a block type for crafting tables again. However, when working on the crafting system itself, that's where the real trouble began, as I thought would be just enough checking for the whole pattern of slots used for crafting, and whenever the pattern matched the pattern of an existing crafting recipe, that's when I got a valid one. As it turned out though, doing just that wasn't enough, as there exists a whole bunch of recipes that are not fixed in pattern and instead rely on the formation of the items put into it. Take the crafting table itself, for instance. In order to craft it, it will need to give in 4 oak planks as a square, which can be all over the place basically. So where you put the square is entirely up to you, and sometimes you even only need a single block in the input field, and having 9 recipes for the exact same items would be a bit of an overkill. Remember, I wanted to make it as easy as possible for us, and my final method of achieving just that was by checking whether there is an empty line or an empty column, and then moving the whole pattern one step into the respective direction, and also diagonally, which made the patterns itself finally end up working. And with that supervillain out of the way, we can finally discuss how I made my game even more authentic compared to the original. How about other types of collectibles, for instance? So far, we've only been dealing with blocks and basically completely ignored consumables, for instance, or just other types of resources like ingots and other crafting materials. That's why I added a whole new scriptable object for those, featuring some additional options like the saturation of consumables, for instance. And I even added those sweet little voxels or 3D objects using an application I found online to make my collectibles look as fancy as you can see right here. To make it stand out even more, I added all kinds of animations to my player based on the player hand you can see at the bottom right. So I set it up to play an animation when walking, sprinting, punching stuff, consuming, and so on. So now it feels even better when you know who you're controlling. Funny enough, similar to most other first-person games, this floating hand model is actually the only thing that really exists, as everything else would just clip into the player's view and require additional effort. But there was the next big problem right around the corner. No matter how small or close to the camera I made the player hand, it would either stop animating properly or clip into whatever thing that was in front of the player. And by looking at how first-person shooters solve this issue, I understood the best way to do that is by rendering the player hand using a whole other camera, so the second camera can ignore everything else and then just laying the two cameras' inputs on top of each other, bringing the illusion back to life. But if you think that's all we can do to make the game feel authentic, well, think again. When inspecting the original game again, one can see there are more survival elements sitting in the hut. Why not adding those too to make the game feel even better? The way I added the UI for HP, saturation and stuff, you already got an impression of. And yes, using Unity's layout groups there to align those single icons was a real blessing once more. And although we might kind of find it a bit annoying when playing ourselves, I also felt a bit obligated to implement saturation too, so the player is depleting it when sprinting and can refill the thing by consuming all kinds of stuff. And not sure whether you remember what we've been starting with, but I think it's starting to look like something you can actually be proud of. But since it feels so hard to think yourself into it, I think now marks the best time to take a look back at the immersion of the game. For instance, I was adding some sounds to it. You know, game engines like Unity have those inspectors to inspect all kinds of data regarding your selected object, which can be perfectly used to assign sounds to the single types of blocks and also to the player. Oh, and there's also music. And for the music in particular, I was able to simply use an audio source, one component of Unity, to attach my background music to make it play in an infinite loop. And not sure whether you realize, but doing it like this isn't too different from how the original has been solving it, as the music artist Notch has been hiring to make the OST with the name C412, I think. They just stated the success and iconicness of Minecraft's soundtrack was due to how generic he was keeping his soundtrack, as he really wanted to make an effort to make sure no matter where each respective part of the soundtrack plays, it still feels good nonetheless, practically taking out the random component of the equation. And since my music file was basically just a mix of all those single tracks, I was hoping I could achieve that effect for my project too. Just take a look and decide for yourself how much better the game feel has become in comparison to the last step, but also in general. Which brings me to the perhaps most important point of my list. What next? Well, what I'm working on right now, besides my video course obviously, is I've been adding Cs, for instance, which look pretty good so far, despite missing water physics as you can tell. Besides that, I want to add even more life to it, like all kinds of mobs, like peaceful ones, and also enemies, like Minecraft's famous zombie. But obviously, there is one big question remaining. What's the result? And the answer is, well, you can download my free demo, obviously, but besides that, I don't really know yet. Maybe it's even the process itself, as this entire project was meant to be for educational purposes from the very beginning. However, you can give it your own purpose by joining my video course I talked about earlier, as right now might be the best time to join before it's too late, in case I need to restrict the access, or we're just too far ahead by the time you're watching this video, as if you like the video, this thing is gonna be the real deal. So what's the result? Well, let's find out together. But before I see you in my course, here's an overview of all the things we've been doing so far.